Hello everyone, this is the Algebra 1 lesson for April 6th. That's Monday, April 6th. And today's lesson should be fairly short because mainly this lesson is to get you to understand some terms and understand graphs a little bit before you actually get into the growth and decay rate that is 8.6. So this is 8.5 exponential functions, and it's just mainly explaining some things before you actually get into exponential growth or decay, where we actually use some formulas and some equations to do things. So if you'll turn to page 350, we'll get started. But first, I'm going to say a quick word of prayer to the Lord. Dear Father, we want to praise you and thank you for everything you do for us, for everything you've done for us, and for everything you're going to do for us. And please help us with our algebra lesson today. Help us, give us understanding. And we pray for both us, for our country, and even for our world. I'm going to add to that you will grant us the wisdom of heaven and help us not to rely on the wisdom of the world. We love you. In Jesus' name, amen. All right, guys, so we're on page 350, and this is a lot of just really an explanation chapter, more so than anything. On your quiz coming up, you do have about 3 questions where they're just seeing if you recognize exponential functions or if you are able to determine what exponential functions are. In today's homework, I'm going to have you do something, not everything that's asking for, but I will have you do some practice for it. But this is actually going to be kind of a shorter lesson, but it may be a more confusing lesson, so you might actually have to look at this and read it and try to get it into your brain. So let's just start slowly and let's look at exponential functions. So we've used linear functions in the past, and they can be used to model many situations. But exponential functions are powerful tools that are capable of representing not only scientific, but also financial things. So you all had probably already used an exponential function. You'll see that at the end of this chapter, that you just you were not aware that it was an exponential function. So let's look at what an exponential function is. And I've written it back here, but you can look on page 350. An exponential function is a function of the form f of x equals ab to the power of x. And one thing for an exponential function to exist is that b must be greater than 0, and b cannot equal 1. And then for your quiz, you're going to have to be able to look at a function and be able to recognize what a is, and a will be a value that you should be able to recognize. And then you should be able to give me parameters of what b is. And when I say parameters, I mean an inequality. Like, you can't just focus on what b is going to be. You kind of have to write a inequality as to a range of values that b could necessarily be. So we're going to go through that. Also on your quiz, they give you a list, not really a graph, but actually a table of values that you could graph. That's one reason why I'm going to get you to do a few tables. And then you have to look at those tables and be able to determine, is it an exponential function? And we'll discuss that a little bit. So first of all, let's just look at example 1. I'm not going to write a whole lot on the board because there's no reason. You all can look at your book on page 350. So example 1, a is y equals 2 to the power of x. And what you need to learn with that, as you look at your orders of pairs of what they did, x is your exponent there. So x is your exponent. So as you can see, if it's just the way it looks like for a, y equals 2x, then that is a graph that's increasing. It's increasing, it's building up, and you should just be able to recognize what that is. Now let's look over at b. b is 1/2 to the power of x. And they want you to recognize that if you've got that, then what is actually starting to happen is that is a decrease. That is an exponential decrease when you have like that fraction and you're using x as your exponent, then it's a decreasing graph or decreasing exponential function. So look at the similarities, look at the differences between those two graphs. Both have an intercept of y-intercept of 0 and 1, and they approach the x-axis, they never intersect it. We call the line y equals 0, or the x-axis, in these graphs, we call that line a asymptote. So asymptote is what that word is. It's a line that a graph approaches, but it never intersects. So the function y equals 2x is showing you a continual increase from left to right. While you've got y equals 1/2 to the power of x, it decreases. The range of our numbers are going to be positive real numbers. They're going to be real, or the exponents in the set of real numbers. We're not going to get into really weird stuff. And one reason that I'm not going to have you graph these is because you don't have to on your test or your quiz, so there's really no sense. But coming up with values and ordered pairs, that may be something you do have to do on a test or quiz, but it's difficult to graph some of these because you can see in example 2, when you graph it, you start ending up with some weirdo fractions. And most of y'all could eyeball it and get those, but I don't want you to have to waste a lot of time doing stuff that you're really not going to have to know for the test or the quiz, when they're just kind of making you try to figure out what a graph looks like or what a graph is doing. What I do need you to focus on is, all right, you're going to have to recognize a decrease and an increase just from not looking at the graph, but from looking at the actual exponential function. So you look at what example 1 is. Y equals 2x, that's an increase. Y equals 2 to the power of x, that's an increase. If it's b, y equals 1/2 to the power of x, that's a decrease. And it could be a different number, it could be a different fraction. You just need to kind of remember that. Now, go to the little statement after example 2, because that's where we're going to talk about if I look at a function, this is on your test, if I look at an exponential function, how can I figure out what a is and how can I figure out what b is? Well, if we look at what a and b is, this is what we're talking about right afterwards. So how does the curve of y equals a times 2 to the x power differ from that from y equals 2 to the x power? Well, for every value of x, the corresponding value of y will be a times its previous value. So since every graph of y equals b to the x power crosses the y-axis at 0 to the 0, 1, then the curve of y equals abx will basically cross the axis at 0 and a. So what did that big long thing tell me? There's going to be a test question, and it tells you in the test question where that graph is going to cross the axis. And it's going to just not even the axis, it's going to say this graph or this line is going to go through this point. And do you see what it just said? It will cross the axis at 0 and a. So at 0 and a. So when you have a test question that tells you, hey, this is an exponential graph, and what is a when it crosses at 0 and 4, or it could be 0 and 5, that's your a. When you see that right there, when it says, hey, this is a, especially it's an exponential graph, they're telling you it's going to cross at this point, then you need to focus on, if x is 0, then that y, that's going to be my a for that one. That's a test question, they ask you that. So let's look at what the other one is when they're asking you what b is. Kind of think about this logically. If B was increasing. You know that B cannot be 0, and B can't equal 1. But if B was decreasing, then B would be greater than 0, but it's going to be less than 1 because it's decreasing. If you're thinking about if D was increasing, if your graph is increasing, then it would be the opposite of that. Now, the one you have on your test, it's decreasing. So technically what you need to know for your test is I would need to write this inequality, that B is basically greater than 0, but B is going to be less than 1. Oh, you cannot see that because it went off like that. You're going to have to know that for your test. So when you have a test question that says, hey, what's an A? What's a B? I'm going to look for the A where I've got a point on the graph. It says, hey, it crosses through this point, and it's that. And then I'm going to look for a function, and if it's telling me, hey, it's decreasing, then I know I need to write an inequality that looks like that. So that's what we're doing for this one. That's 2 big things you have to know from this chapter about exponential functions. Then they start trying to give you some real life situations. They've got the photocopier problem here that you might, that you can look over if you want to try. But I wanted to point out one because you've actually done this one in the 7th and 8th grade, maybe the 8th grade. Maybe I can't remember 7th and 8th very well, but I remember you all doing this one. So I want you to look at example 4, and I forgot something, so let me, if I can find it. I need my phone or I need a calculator, but I was going to show you how to do it on your phone. Okay, I am back. I left my phone over there. So let's look at example 4, and then I'm going to show you how to do something on your phone or to show you what button to use if you have it on your scientific calculator. So if you look at example 4, we've studied problems with very simple interest, and simple interest means you get it at one time at the end of an investment period. Most investments, though, involve compound interest, and if you don't use an exponent with this one, it can get really crazy. And I don't know if you remember doing that. We actually did that a little bit in 7th and 8th grade. You would have to do the simple interest formula, add it back in, and then do it again, and then add it back in, and then do it again, and then they gave you this real simple formula, and you're like, why did we have to do all this? Well, that's what they're showing you in example 4. Most investments involve compound interest, where interest is regularly credited to the account so it can begin earning interest along with the principal. Compound interest can be modeled with an exponential function. And that's why I wanted you all to maybe think back to 7th and 8th grade where you might have had to do that compound interest over and over and over. And then that was to introduce you to this exponential function, but they didn't call it that. They just said, hey, this is an easier way of doing it, but we're using an exponent. That's what example 4 is. What I wanted to show you down here, though, is using this example, maybe how you can do an exponent on your calculator or your phone. Because I know some of you probably have a scientific calculator. I don't have one. Well, I mean, I've got some here that are really high tech. But and you all know I do not like calculators. This is one place where you might need a calculator simply to use the exponents. Now, most of you might have an iPhone, or if you have an Android, some type of thing like that, you know that when you have your calculator, it normally looks like that. And most of y'all know your phones more than I would, but just in case you don't, if you turn your phone, it becomes a rudimentary scientific calculator, which is perfectly acceptable to use for this exponential function that we're going to do. So I'm going to go all the way down, and I want to figure out if I put in $10,000 and I left it in there for 50 years at an interest rate of 1.05, which is really good interest rate at this point. I want to know what exactly would that be. And so I'm going to show you how to do that on there. Now, of course, in your example, they've already done it for you. But I want to, first of all, I'm going to compound my interest first. And then I'm going to multiply that to what my principal is, because I probably could do, the parentheses, but I'm not going to show that to you. So let's look. I'm going to punch in first the interest rate, 1.05. And then you are going to look, and it's like, okay, I could square it, I would hit the x squared. I could cube it, it would hit x cubed, but I'm getting closer. But if you notice the next one, it says x to the y power. And so that's the one I want to use in order to increase my function higher than cube. So I've got 1.05. Now I'm going to hit x to that y power. And the next button I'm going to hit is going to be what I want that power to be. And so I want that power to be 50. So I'm going to hit 50. And then I'm going to hit equals. And it's going to give me this big number, like 11.4 or whatever. Now I'm going to take that number and I'm going to multiply it to what my original principal was, and my original principal was 10,000. So, boop, 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 boop. All right, there's 10,000. Then I'm going to hit equals. And then if you notice what I got, it said you got $114,674. They simply rounded up what I've got right here, because you basically got 99 cents and it's rounding up, and they just rounded it up to $114,674. That's how you use that exponent function on your smartphone. Now, what I want you to do is let's look at your homework. Now, if you were this is one of those things where it says to do, the recommended lesson is 1 through 25 odd. I do not want you to graph on this one, because I think it's probably a waste of time and it's going to be really difficult for you to graph. But what I would like you to do is let's look at that first section. That first section is where they actually want you to evaluate x. So let's look at number 1. I will erase, if I can find an eraser. I can get rid of all of this stuff here. Yes, I am sitting, because I about wore myself out trying to stand at the last lesson. So number 1, we're on your homework on page 352. 1 looks like this. Y equals 1/2 to the power of x. And you can already tell yourself, wow, I've got this fraction going on. Wonder what's going to happen to that. And you could probably say, oh, that was an example we had of a decrease. This is going to be a decreasing curve, not an increasing curve. But if I made x 5, what would that be? So if we made x 5, then what would that be? Now here's where you don't want to kill yourself on this one. If you try to start putting in 0.5 in there, you're going to get a decimal. That's not what they're looking for. They're not looking for the decimal. This is still not going to be hard though, okay guys? You know it's going to end up being a fraction. So, because 5, 1 to the 5th power, that's 1 times 1 times 1 times 1 times 1. It's just going to be 1. So what do I actually need to increase? Well, what do I need to increase is that 2. I want 2 to the 5th power. I'll go back to my handy-dandy smartphone, because that's probably what the majority of you are using, because some of you might not even have a calculator, or you may not know where your calculator is at, and I don't have one either. So right here at hand, I'm going to stick in 5. I'm going to stick in, now I'm going to hit, wait a second, not 5. I'm going to stick in 2. That's what I'm doing, sorry. Stick in 2, because that's what I'm going to increase. It's like 2 to the 5th power right here. And then I'm going to hit the x to the y button. Did I hit? Nope, there. X to the y button. And now I'm going to hit 5. And that gives me 32. So my answer to number 1 is 1 to the 32nd power. Now, if you have a scientific calculator, they probably have a button or a function somewhere like that. It might be that you have to hit a function key in order to get that. If you're frustrated with that and you've got your smartphone, then just use this one if you can't find it right off the bat. But normally it's going to look like x to the y power. I think I've had some kids who it may have been reversed. It might have said y something, but it's going to look something like that in order to get that. Then they have done different functions for you. Once again, like number 2 is where, what would 3 be? If I make x to the negative power, now you could do that totally on your calculator and make it into, put in -4 for your exponent. If you don't have that much stuff, and I'm going to see if it works right here. Not tried that, but let's try. So I've got 3, and I'm going to hit this, and then I want it to be, right here I have the negative, I want it to be a -4. -4. And it gave me this weirdo fraction, so don't use that. I'm going to tell you what to do. If you have a negative exponent, remember? That wasn't a weirdo fraction, that was a weirdo decimal. If you have a negative exponent, that just means you're going to make that into a fraction. So don't kill yourself with that. Let's just look at how we're doing it. We're going to take that, y equals 3x, 3 to the x power, and they want it to be y equals 3 to the -4th power. If I remember, we just make that into a positive by doing this. Remember, this was at the very beginning. I'm going to make that y to the 3 to the 4th power right there. So now, I know that's just going to be a, and that would be a decrease, wouldn't it? So that, I'm just going to make that a 1 right there. And then we're going to take the 4, not 4, we're going to take 3, flip her back over. We're going to take 3, hit that y to the x to the y power, then hit 4, and I've got 81. And that's what I'm going to put in my fraction, is an 81. So there, you've got that far. What I want you to do on this is do some of these tables. You all pick out which ones, and then notice what happens to your values. So and you can kind of just get that in your brain. Just choose a couple under number from 5 through 11. Do not graph. Remember I said do not graph in this because it's frustrating, useless in my opinion. But notice what happens. Like on number 5, I have 3 to the x power. Your values should increase. It should make this increase that's happening. On number 6, I've got this fraction to the x power. My value should decrease in that, and I should be able to recognize that. Then they're just asking you some questions up here, like from 13 through 16, they're just asking you some questions about exponential functions, and some of that might help you trying to understand it a little bit. You do not need to do any of the, if you want to do some stuff through B because you're like totally just bored, go ahead. I will tell you, but you don't have to, but I will tell you, question 22 looks somewhat similar to one that they set up on your test, so you might want to go ahead and just kind of work through that. Your test isn't divided up the way they got it like that. They have it right there, so that might help you on your test. One thing I did want you to look at is down here at the bottom, if you complete some of these tables, like 23 through 26, on your quiz, you have one question where they just give you a bunch of tables. And then they ask you, which of these tables is an exponential function? And you need to think, if it's an exponential function, it is my x is going to be this exponent. And so it should be increasing or decreasing. Y should be increasing or decreasing. It shouldn't be just staying the same. And it should be increasing and decreasing by an exponent. And you just need to kind of think that out. So this is a short lesson today because I didn't really see the value of having you do everything on here, but it is kind of confusing. So I do want you to sit down, try to figure out what you're doing, and see if you understand what this is. If you have questions, you can leave me a comment, or you can, text me through your parents' phone, leave a message in Facebook, whatever you need, and then I'll just we'll set up a FaceTime, we'll do something like that. But other than that, have a great Monday, April the 6th, and I will be back and give you a video on April the 7th. That's going to be over 8.6, where we really get into some meaty word problems. On April 8th, we are going to just review. I'm going to probably take your test and just go through each problem of your test and say, hey, it's from this section, or hey, it's from that section, just to focus you a little bit so you can start working on your test. We're picking up your test in a packet on Monday. Remember, on this Monday, you should have picked that up. Your test contains a quiz over 8.3 and 8.4, and it also contains a quiz on 8.5 and 8.6, and then it also contains your test. But I'll do a video on April the 8th that's just telling you these problems come from this section of your test, or from this section of your chapter. I'm not doing another video. So the rest of it, time will be for you working on your tests, working on your quizzes. You turn all of that back into me on April 13th, and on April 13th is when we'll start Chapter 9. So have a great rest of the week. Tomorrow we'll do 8.6. Wednesday we'll do just a review of your test. And have a great day. Love you guys and miss you, and stay well. Make sure you wash your hands often and don't touch your face.